Hello, I'm Zhuoying from Peking University, and I will present our work Balancing Preservation and Modification, a region and semantic aware matrix for instruction-based image editing. This work was done in collaboration with Zhu, Yuxin, and Yang. This work primarily addresses the challenge of evaluating instruction-based image editing. An example of instruction-based image editing is illustrated in the left image. Currently, mainstream evaluation matrices can be broadly categorized into two types: those that assess image-text similarity, such as clip text, and those that evaluate image-to-image similarity, such as clip image. However, these matrices frequently do not align with human judgments, as shown in the right image. So what are the primary issues with existing matrices? First, they are not specifically tailored for image editing tasks. Second, they evaluate the entire image as a whole, without accounting for the fact that some regions of the image need to be preserved, while others require modification, as shown in the image below. To address these problems, we propose a new matrix for instruction-based image editing. The core idea is to explicitly divide the image into editing area and non-editing area. We first utilize large language model and grounded them to localized editing area. Then we conduct region-aware judge to verify whether the editing follows the instruction for region size and position. And for semantic-aware judge, we measure the conformity to editing instructions in the editing area and assessing the preservation of the original image in the non-editing area. Specifically, for edit area localization, we first utilize large language model to pass editing instructions, including editing object recognition, object localization, and size modification determination. Then we employ grounded SEM to localize the editing region based on the passing results. Then, for region-aware judge, we verify whether the changes in size and position align with the textual instructions, as shown in the two below images. For semantic-aware judge, in editing region, we assess the consistency with editing instructions by using directional clip similarity, and in non-editing region, we assess the consistency with the original image by using L2 distance. Furthermore, considering that our pipeline generates accurate editing region mask, we utilize the located editing region as the guidance for image editing model, leading the model to focus attention on the regions that need editing. For experiments, we have two evaluation settings: human alignment test and ground truth test. For human alignment test, as shown in the tables, our matrix achieves the highest degree of alignment with human scores for both local and global edits. And for ground truth test, our BPM matrix favors the ground truth images, that is, the well-edited ones with 87% ratio, and surpasses GPT-4o results. And we also find that image similarity matrix like L2 distance prefer excessively preserved results, while image test matrix like clip score prefer excessively modified results. We also evaluate the effectiveness of mask guidance enhancement, and we find that both user study and evaluation by BPM matrix show that our mask guidance can enhance edit quality, particularly by improving the consistency of the edited image with the original. And here are two visualization examples of our BPM matrix and our mask guidance to the image editing models. In conclusion, we introduced a novel matrix BPM for instruction-based image editing, which evaluates editing quality from the region and semantic perspective with explicit disentangled separate consideration for editing relevant and irrelevant region. And it shows a high correlation with human evaluation and outperforms previous matrix. That's all, thank you. The project page and code are available by scanning the QR code. Thank you for your attention.